All right, as we were reviewing and getting ready for the Chapter 4.5b test, one other question came up. And this is from a mom question. It's from Appendix B, the extra practice on Appendix B. And it's problem number 11, or question number 11. And this is about the characteristics of logs. This is an important one to study because it helps you understand the basic characteristics behind a log function. Now, one of the things that's really helpful is to know the basic shape of a log graph. Now, I can't do it on pencil and paper here right now because of my computer limitations, but I do have a program that's going to graph it for me. But all you need is the basic sketch of the graph. So the basic sketch would have something like that. And it's going to have these points. Those are very specific points that work in log. So if I plug in 1, log base 5 of 1 equals 0. That's why I get this exponent. And if I plug in 5, log base 5 of 5 is 1. I get the 1 exponent. And I have two really nice points in this graph here. Now there's one other thing in the graph, which is an asymptote. The asymptote is always on these basic log graphs, it's always on the x equals 0 line. Okay, so I'm going to hide all that information so we can just look at the graph here. Now, while we're looking at the graph, we can see the domain. You can see my highlighting cursor. I'm pointing at a bunch of x's, and all these x's make the blue graph. But if I go to the other side, negative x's, there's no graph. That's because these x's are not in the domain. So when we do the domain here, it's going to have to be 0 up to infinity. And let's talk about the range. Going back to the graph, the range is the y numbers. Now up here is a positive y number. You can see my cursor, and eventually this positive y number will land on the blue graph. And if you look at the blue graph here, these y numbers go down forever. They're hidden by the asymptote, but they are there. So the y numbers are going down forever. So the range is all the y's. All these y numbers are part of the graph. So it goes from negative infinity up to positive infinity. And it does not look like it liked my infinity. I'll use that one there with a comma. And now I got that one. Now, horizontal intercepts. Does it cross the horizontal axis? Well, right here we can see clearly all log functions cross. The basic ones always cross at 1, 0. So we were good on that one. Y asymptote. There is a y asymptote. That is the red line. Now the y asymptote is a line. It's not a point. It's not a number. It's a line equation. So I have to say x equals 0. And vertical intercept point. Well, wait. If there's an asymptote, it never crosses. This blue line is never going to cross over to the other side, so you never get a point here. That's the whole thing with that vertical asymptote. So here we're going to have to say does not exist. Okay, now here the question's a little bit more complex. Left and right behavior. Is the graph of log increasing or decreasing? Well, we can see these y numbers. I'm going to take the intercept off for a moment. And let's zoom in. So we can see these blue parts of the graph. These y numbers are shooting up from here, shooting high, 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 and then they're shooting up, and they're going to increase. They get taller each time. So the left-right behavior is increasing. Now the next question, is it increasing at a constant rate? Well, the y's jump from here to here really fast. But then the y's went from 0 to here not too fast. And over here, the y's went from 1 up to here really slowly. Okay, so the rate of the y's are still growing, but they're growing at a slow rate. So each step, the y's are getting higher, but they're getting higher at a decreasing rate. So it's slowing down how the y's are growing. Okay, next, let's look at the f of x. What f of x has to be positive. Now, if you see the yellow cursor, here's a y number, and it's positive. Another y number, positive. So here f of x is positive on this whole part. All of this part of the graph has positive y. So what are my x numbers that are making all these positive y's? Well, those x numbers only start at 1. And these x numbers are the x numbers that make the y part positive. So over here, it says use inequality notation. So we would have to say x has to be greater than 1. Now, let's go back and say, okay, f of x is negative. That means the y's are negative. Okay, so see the yellow cursor. Here I'm pointing at the graph, and these are y numbers that are negative y numbers. Okay, so all of this part of the graph has negative y numbers. So what x's are making these negative y numbers? These x's here are the x's that make the y's negative. So those x's are between 0 and 1. So we're going to use inequality notation and say 0 is less than x is less than 1. Okay, now this says f of x has to equal 0, or y has to equal 0. Y has to equal 0. Okay, well, hey, right here, this is my horizontal intercept point, y equals 0. So that means that only happens when x equals 1. And then lastly, f of x has to equal 1. So f of x equals 1, that means y equals 1. So y equals 1, oh wait, we already had that point up there and I took it off. No, I didn't. It's just off the screen here. I'll zoom out. There it is. Y equals 1 right here when x equals 5. So x equals 5. And let's check and see how I did. I want to make sure I didn't miscommunicate anything on there. But it says I got them all right. So anyways, I hope that video was helpful to help you break down the characteristics of logs. Study hard for this test, and I'll see you in class.